Let's see question 5. What dividing polynomials? So this one is polynomial degree 3. This is polynomial degree 1. So the solution should be either polynomial or maybe with remainder. The remainder will become a rational expression. So anyway, the leading term of the quotient should be polynomial degree 2, because this is a 3, this is a 1, 3 minus 1 should be 2. So when we divide by this called monomial, so we just divide each term by this monomial. So let's rewrite. So we have 4x cubed divided by 2x plus 6x squared divided by 2x plus 10x divided by 2x plus 2 divided by 2x. So every term divided by 2x. Or 4x cubed divided by 2x. 4 divided by 2, we get 2. X cubed divided by x, that's x squared. So the first term, get 2x squared. The second term, 6 divided by 2, get 3. X squared divided by x, that's just x, so get 3x. 10x divided by 2x, x divided by x becomes 1. 10 divided by 2 becomes 5. So that's 5. Then the last term, we have 2 divided by 2, that becomes 1. So last term is a rational expression, 1 over x. So that's the division. So after division, that's the quotient, right? So quotient with a remainder 1 over x. So here, same thing. So we could write a -6 under this. So -6x squared y squared. So it's easier to see it. So first term divided by -6x squared y squared. 24 divided by -6, we get -4. That's right here. Then x raised by 5 divided by x squared. 5 minus 2, that's x raised by 3. Y to the 7th power divided by y squared. 7 minus 2, that's 5. So y to the 5th power. So the second term, -18 divided by -6, that's +3. X raised by 4 divided by x squared. 4 minus 2 is 2, so we have x squared. Y to the 4th power divided by y squared. 4 minus 2, 2, so we get a y squared. Then 3 divided by -6, that's -1/2. X cubed divided by x squared, that's x. Y squared divided by y squared, just 1. Well, half x multiplied by 1 is still -1/2x. So that's it. But look at it. This x on the side of half. So half of x is not in the denominator. So this is more like a polynomial. Now let's see this one. So we're required to use long division to divide this. Otherwise, we could use short division. So with long division, we make this sign. Then we put the radicand, so we call this radicand, or the dividend inside. So we have ax cubed minus 10x squared minus x plus 3 divided by x minus 1. So let me change my color. So our goal is to get rid of these terms one by one. So we want to put in the quotient put above this. We want to match, we think, what's ax cubed divided by x? That's ax squared. Right, we use this leading term divided by this leading term. Ax cubed divided by x, that's ax squared. Then we use -1, so multiply this -1 with ax squared, so we get a negative ax squared. Well, of course, the first term is get x times ax squared, which is ax cubed. We don't really need to write it because each step we're going to subtract. When we subtract, this becomes 0. So negative 10x squared minus negative ax squared, negative 10 plus a, right? That's negative 2x squared. Then we pull the next term down here, negative x. Then we think, what's the negative 2x squared divided by x? Well, that's negative 2x, right? Because every step we're matching up. So this quotient depends on this leading term and this x. So we don't really have to write this. Write the negative 2x squared underneath. We just do -1 times negative 2x, we got a positive 2x. Then each step we subtract. Negative x minus 2x, negative 3x. Then plus 3. So now negative 3x divided by x, that's negative 3. So we put negative 3 here. So we get -1 times negative 3, that's positive 3. So when we subtract, we get 0. So the remainder is 0. So that means, so the answer for this, we can write here. That's ax squared minus 2x minus 3, no remainder. So that means this, the quotient and this multiplied by the divisor equals to the dividend. Or to say the dividend can be factored as 2 factors. One is x minus 1, another one is ax squared minus 2x minus 3. Okay, that's A. Let's see B. The steps are the same. We make such sign. We put the radicand inside, so 2x cubed, or the dividend minus 7x squared plus 4x plus 3. Then the divisor, we write outside 2x minus 3. Each step, we're doing the same thing. Let me change my color. We're going to do the leading term divided by the divisor. So the first step, we're going to use this one divided by this one. 2x cubed divided by 2x, x squared. Right. Then we multiply -3 with x squared, we get negative 3x squared. So we subtract. Negative 7x squared minus negative 3x squared is the same as negative 7x squared plus 3x squared. So we get negative 4x squared. Then we pull the next one down, which is a plus 4x. Now we use, let me change my color again. Now we use negative 4x squared divided by 2x. Negative 4x squared divided by 2x, that's negative 2x. Yeah, right? Or think of negative 2x times 2x, that's negative 4x squared. So negative 2x times negative 3, that's a positive 6x. Then we subtract. 4x subtract 6x, negative 2x. Then pull the next one down, plus 3. Now we just need to put -1 here, right? Because -1 times 2x is negative 2x. -1 times negative 3, positive 3. Again, when we subtract, the remainder is 0. So the answer for the second one is x squared minus 2x minus 1. No remainder, right? So which means the dividend can be factored at those 2 factors. So we can treat the quotient as a factor, the divisor as a factor. Now let's see C. See, the dividend is x cubed plus 9x squared plus 24x plus 19, all divided by the divisor put outside, x plus 5. X cubed divided by x squared. X squared times 5, 5x squared. Subtract, get 4x squared. The next one is 24x. 4x squared divided by x, 4x. 4x times 5, 20x. Subtract 4x. Pull next one down, 19. 4x divided by x, 4. 4 times 5, 20. Minus 19 minus 20, negative 1. So this one we have a remainder. So how do we write it? We write the quotient first. X squared plus 4x plus 4. So this is the quotient part. So minus 1 is 1 over x plus 5. So this will show negative 1 is a remainder. Right? So the first two cases, remainder is 0, but not for this one. This one we do have a remainder of negative 1. Now let's see D. D, we see we're missing x term, right? We have x cubed minus 12x squared, no x term. So we need to make a 0. We need to write a 0 to take the spot for x. So x cubed minus 12x squared minus or plus 0 minus 42, right? Because we're missing x term. So we just put a 0 here to take the spot. Then the divisor is x minus 3. So we put the x squared here, then negative 3x squared. Subtract, then plus. So get negative 9x squared. Then no x term, that's a 0. We need a negative 9x here. So negative 9x times negative 3 become positive 27x. We subtract, get negative 27x minus 42. So we need to put a negative 27 here. Negative 3 times negative 27 becomes positive 81, isn't it? Yes, 81. Then negative 42 minus 81 becomes negative 3, 1, 2. Negative 1, 2, 3. So the answer for this one, we have a remainder also. We write as x squared minus 9x minus 27 minus 123 over the divisor x minus 3. So this is a quotient, this is a remainder. Now let's see E. E of 14 x raised by 4 minus 5 x raised by 3 minus 11 x squared minus 11x plus 8. The divisor is 2x minus 1. Okay, so 14x raised by 4 divided by 2x, that's a 7x cubed. Then minus 1 times 7x cubed. Minus become plus. So 2x cubed minus 11x squared. Then 2x cubed divided by 2x, x squared. -1 times negative x squared positive x squared. Subtract -11 minus 1, -12 x squared. Next term, -11x. So -12x. Then -1 times negative become positive 12x. Subtract -23x. Move the next one down, which is the number 8. Now we get a fraction. So we need to put a -23 over 2, right? Because -23 over 2 multiplied by 2x, 2 canceled, that equals -23x. So now -1 times -23 become positive 23 over 2. We subtract. So 8 subtract 23 over 2. We change this to be 16 over 2 minus 23 over 2. Well, 16 minus 23, 7, right? -7. So get a -7 over 2 as a remainder. So how do we write? We would write equal sign, then write the quotient. This is a quotient. Write the quotient, including fractions. The quotient is 7x cubed minus x squared minus 12x minus 23 over 2. Then minus the remainder. How do we write the remainder? The 7 over 2 times, don't forget the divisor, 2x minus 1. All right, so the quotient, then minus this, 7 over 2 times the divisor, 2x minus 1. Okay, that's E. Now let's see F. Well, 4x raised by 4 plus 18x cubed minus 18. Oh, hold on, we don't have an x squared term. So let's put 0 here, take the spot. Then to the plus 0 minus 18x plus 6. All divided by -2x plus 3. Now we think about the 4x raised by 4 divided by -2x. Positive divided by negative, so get negative. 4 divided by 2, get 2. X raised by 4 divided by x, get x cubed. 3 times -2, x cubed becomes -6, x cubed. Minus negative become plus. 18 plus 6, then 24, x cubed plus 0. Then 24x cubed divided by -2x, that's a -12x squared. So 3 times -12 get -36x squared. Minus negative become plus. Move the next one down, -18x. Now divided by negative, so 36x squared divided by -2x, get -18x. Then 3 times -18, get -54x. Subtract. Subtract become plus, so get 54 minus 18, which is 6, 3, right? So get positive 36x. So move 6 down, plus 6. Well, 36 divided by -2 is a -18. Right, -18, then 3 times -18, that's a -54. Subtract 6, subtract -54 becomes 6 plus 54, which is a positive 60. So the answer for this is equals to, first we write this quotient, the quotient part. Then we write add 60 over the divisor, negative 2x plus 3. All right, that finishes the long division part. Now let's see 7. 7, want to solve rational equations. Rational means the variable x appears in the denominator. Okay, so for the first one, we have a rational expression, one rational expression on the left-hand side, and one rational expression on the right-hand side, on the left-hand side. So something we could do is called a cross multiplication. One example is like this. If I have 1 over 1 plus 2 equals to 2 over 2 plus 4, right? This is right? Because 1 over 1 plus 2 is 1/3. The right-hand side, 2 over 6. 2 over 6 can be simplified as 1/3. So one thing we could do is called a cross multiplication, which means I can do this. I can do 1 times 2 plus 4. Well, 2 plus 4 is 6. 1 times 6 is 6. That equals to 2 times, so this is 3, equal to 2 times 3. Right, so this is called a cross multiplication. Cross multiplication. So we could apply that with this one. So we're going to multiply those two, and that equals to multiplication of those two. So I have x times x plus 6 equals to a times x plus 3. X times x, x squared. X times 6, 6x equals to a times x, ax. A times 3, 24. Now this is quadratic equation. Quadratic equation will move everything to the left-hand side and leave the right-hand side to be 0. So x squared plus 6x, move ax to the other side, becomes negative. Move 24 to the other side, becomes negative. 6x minus ax, like terms, combine to be negative 2x minus 24 equals to 0. Now we need to think about two factors of negative 24 adds up to be negative 2. Well, that should be negative 6 and positive 4. Because negative 6 times positive 4 is negative 24. And negative 6 plus 4 is negative 2. That's how we got this middle term. So by zero property, we can split each factor to be 0. I solve each equation, get 6, I get negative 4. So I have two solutions for A. Now let's see B. For B, if we want to do that, we could do that, something with this one, with A. Let's try that. So I see these two terms have a common denominator. So I can combine those two terms. So we want to move this one to the left-hand side and move this term to the right-hand side. So we do x minus 1 minus 1 over x minus 1 equals to positive 2 over x. Because with the equation, we can always move a term from left-hand side to right-hand side or from right-hand side to left-hand side by changing the sign, right? So if one is right, positive on one side, when we move to the other side, it becomes negative. If it's all negative and move to the other side, become positive. So now I have a common denominator for these two terms. So I can simplify this. I can do the subtraction with the numerators. So x minus 1 divided by x minus 1. That equals to 2 over x. Well, x minus 1 divided by x minus 1 is equals 1. Now I multiply x on both sides. And so I get x equals to 2. So one solution. X is 2 for B. Now let's see C. C on the, so we have 3 denominators. So x squared plus x minus 6. We see this can be factored as x plus 3 and x minus 2, right? So basically this one and this one multiply to be the common denominator. So in class, I taught you to use the method of this multiplying by the common denominator, right? For every term. So I have this one. We look at this as one term. We look at this as one term. We look at this as one term. So every term we want to multiply by this least common denominator. So when I multiply this least common denominator with this one, so everyone multiply with this, right? Every term multiply with this. The first one on the left-hand side, when we multiply, we get a 20. Because this common denominator and this common, because this one and this one are the same. So the numerator and denominator are the same, cancel each other, so we're left with 20. And then the second term on the left-hand side, we have 6 over x plus 3. So we need to multiply x minus 2 divides itself. So 6 times x minus 2. Then on the right-hand side, when we multiply by this least common denominator, x minus 2 divided by x minus 2 becomes 1. And we're left with a 5 times x plus 3. So 20 plus 6x minus 12 equals to 5x plus 15. Right? So we'll move 5x to this side. So I have 6x minus 5x. On the other side, we have 15. Now this side, we have 20 minus 12. That's positive 8. Move to the other side, becomes minus 6x minus 5x is 1x. 15 minus 8, 7. So get a one solution. Get a one solution. Okay, very similarly for D. We see this one is the least common denominator, right? Because this one can be factored. So this, I can factor this as x minus 4 times x minus 3, right? I can put this trinomial into 2 binomials. So that means the first one, so we can multiply every term with this one. When I multiply this one with the first one, x minus 4 divided by x minus 4, simplify to be 1, then left with 4 times x minus 3. Then plus 3, this term, when I multiply by this common denominator, x minus 3 divided by x minus 3 becomes 1, so I'm left with 3 times x minus 4. Then equals to, well, this one times this, the denominators are the same. So just left with 25. So then distribute. This is 3. So I have 4x plus 3x, that's 7x. I have negative 12, that's negative 24. Then I move negative 24 to the other side, become positive. So 24 plus 25, that's 49. Both sides divided by 7. So x equals 7. So one solution. All right. Now let's say 8. A is also saying solve each formula for the specified variable. So A, we want to solve for C. So how do we solve for C? First, we want to multiply by n on both sides to get rid of this denominator, right? So get R minus C equals to n multiplied by P. And our goal is to solve for C. So so we have negative C, why don't we move negative C to the other side? It becomes positive. So move this NP to the other side, it becomes negative. So rewrite it, we just have R minus NP equals to C. So C is solved. C equals to R minus NP. Well, let's see B, we want to solve for B. So first, let's move 1 over A to the other side. Right, move this term. So we have 1 over F minus 1 over A equals to 1 over B. Now, let me change my color. So I have these two fractions. So I could do this. Multiply those two, multiply those two, multiply this. So what I get is, I get F times A in the denominator. 1 times A is A, 1 times F is F. So this one becomes this one. Now equals to 1 over B. But I'm solving for B, so I can flip over the numerator and denominator, right? The example is like this. Half equals to 2 over 4. So if I can flip this to see 1 over 2, 2 over 1 equals to 4 over 2. Because it's the equation, right? So that means if I flip this, I get a B equals to FA divided by A minus F, right? So here FA is denominator, B is the denominator. So when I flip over, B becomes the numerator, and the FA also becomes numerator. And the numerator before becomes the denominator. Well, 1 over B, when they flip over, there's B over 1. But usually don't write B over 1. We just write B. B over 1, just B. So B is solved. B is FA, F times A divided by A minus F. So we have 9, 10, 11, 12. So all those are word problems. Okay, I'm going to take a break. So I did a 5 to 8.